Namaskar my dear friends. Let us talk about voltage divider circuits in analog circuit design. So voltage divider circuits is very important and they are abundantly used in analog circuits wherever you see any circuits that is there. So let us say we have a input voltage and our aim would be to identify R1 and R2 in such a manner that we can find out our Vx. So Vx is the voltage which is going to be let us say going to go to input to ADCs or like comparators or somewhere. So our aim is to design this R1 and R2 in such a manner that Vx is well below the reference voltage, right? So you would have seen many of the circuits. Let us say we have this kind of circuit which is like VDD has to be monitored like continuously. Let us say it is around 3.3 volt or let's say 5 volt, anything is fine. So in that case we try to design circuits like this is R86 and R87 in such a manner that VDDX is a voltage which is well below like ADC voltage reference, let us say 2.5 voltage reference. Okay, then we send it to my buffer and then it goes to low pass filter and then it goes to my ADC input line. Similar to that, other circuits may be possible, like we have a variable resistor like potentiometer, and this potentiometer is having total 10k, and as the wheel moves up and down, the voltage at this particular node will vary. Let us say like Rx and Ry is going to be equal to Rx plus Ry is equal to 10k, right? So this is again going to actually create a voltage division. You would have seen many FPGA circuits and somewhere where you need to design the output voltage regulation as well. Let us say we have to have a 5 volt regulator, we have to have 3.3 volt, 1.8 volt, 1.2 volt, right? So you need to design the output feedback resistor, like you can see here R1 and R3 are making combination of like voltage division from this place to this place and this place to this place. So this particular voltage which is going to be nothing but your FB1, similar to that FB2, similar to that FB3, FB4. So there are ample amount of requirement where you need to design your voltage divider circuit. All right. So our aim would be to identify or to calculate how quickly we can find out the voltage at this particular node. Not only that, if any of these four parameters, let's say my input voltage, my required voltage Vx, my resistor R1, my resistor R2. So any of these four, if you want to identify, we can very easily identify, right? You would have seen many of the other circuits, like let us say we have V1, we want to send it to like a sense input so that we can keep on monitoring through an ADC channel. Similar to that, let us say we have V2, we have V5, we have V6. There is a possibility that V1 is let us say 12 volt. Let us say V2 is let us say 5 volt. Okay, V5 can be let us say 15 volt. So anything can be a possibility. It can be let us say 3.3 volt. Okay, so similar to that, other voltage can be possible. Let us say like V3. So V3 is let us say it is having how much I can tell you. Let us say it is 9 volt, and let's say this is again like 10 volt or something. Okay, so as you can see, we have resistor R1, R2, R1, R2 everywhere, and our aim is to identify which is my Vx and how to calculate this very quickly and understand that our voltage that is going to be monitored is well within the range. Okay, so let me give you a calculation so that you can have a proper understanding and incorporate in your analog circuit design. Okay, so what happens is basically the importance and all about voltage division in analog circuit we will try to understand using this particular circuit. Okay, so let us say we have input voltage here, and then we have to find out Vx, and we have R1 and R2. Okay, so what will be the voltage Vx? As you can see from the circuit, you already know how to identify Vx. Vx is very easily can be written in terms of V input as Vx is equal to R2 times V in divided by R1 plus R2. So this is our node voltage, which is going to be Vx is equal to R2 into V in divided by R1 plus R2. Now we know V in, and any one of the like both the resistor, if we know like R1 and R2, then we can find out what is my Vx. Similar to that, let us say if we know all other values and v in we do not know, right? So from here we can find out v in is equal to vx into r1 plus r2 divided by r2, and r2 got cancelled, so 1 plus r1 by r2. So this is one more formula that you can take up. Okay, similar to that, what we can do is we can try to like calculate other values as well. So other values, how we can calculate? Let us say we have Vx is equal to what? R2 into V in divided by R1 plus R2, right? And this is the circuit that is there with us. So this is my Vx, this is my R2, this is my R1, and this is my V input. Okay. So now let us say that we want to identify here R1. R1 is equal to what? Let us say all other values are there. I am going to assume a value of R2. How we can find out R1 value? So from here we can solve it very quickly. What we can do? Vx into R1 plus Vx into R2 is equal to R2 into V in. So from here, can I write it down? R1 is going to be equal to R2 I will take common, so R2 times V in minus Vx divided by R1, Vx. Or if you do not understand, I will write it again. What will happen is nothing but V in into R2 minus Vx into R2. So this is the complete thing that will come, and that is going to be equal to Vx into R1. So R1 will go down. So this is how the value is. So this is another formula. Now let us say we have we have to find out R2, not R1. So what we will do? We will again calculate the same from this formula. What will happen? Vx into R1 plus Vx into R2 is going to be equal to V in into R2. Okay. So from here, can I take down R2 common? So I can take like this. V in into R2 minus Vx into R2 is equal to Vx into R1. Okay, so I took Vx into R2 that side, and this is all taken left side, right? So from here I can write it down. R2 is equal to Vx into R1 divided by V in minus Vx. So this is another formula. Okay. So we have all the four formulas that is there: R1 formula, R2 formula, and then we have Vx formula as well as V in formula, right? Now I'll just give you a calculation exactly like what will be the voltage at this particular Vx node, right? So let me open an Excel sheet. I have prepared it for you. So okay, so let us say we have input voltage V 12 volt. So this is V in is 12 volt, and Vx has to be like 1 volt. So what will happen? If we put R1 is equal to 11 kilo ohm, then R2 will be calculated to be 1 kilo ohm. Okay. Similar to that, if I keep R1 is equal to 10 kilo ohm, okay, then R1 will become 909 ohm or 0.909 kilo ohm. Okay. Similar to that, if V input is 3.3 volt, what will happen? And I have to find out Vx to be 1 volt, then what will happen? R1 will be 10 kilo ohm, R2 will be 4.34 kilo ohm. Okay. If you want, you can vary by yourself. Like let us say I want it to be 2.2 kilo ohm. In that case, R1 and R2 has to be like this. Got it? So this is kind of calculation for R2. So I am going to calculate R2. Okay. Let us say I want to calculate R1 in this. So what will happen? Let us say we have input voltage as 12 volt. Vx to be find out is 1 volt, and R2 has to be given is 1 kilo ohm. So in that case, R1 will be what? 11 kilo ohm. Okay. Let us say V in is 11 volt. What will happen? R2 will be 1 kilo ohm, R1 will be 10 kilo ohm. Understood? So this is very basic. However, this is very important. Okay. Sometimes what happens is it is very difficult. Let us say V input is, let us say 180 volt. Okay. And our aim is to keep Vx to be like less than 2.5 volt. So what do you think? Let us say we will keep like 2 volt. So if you want to keep 2 volt, what will happen? Let us say my V input is 180 volt and Vx is 2 volt. So can you design a value of R1 and R2 in that case? So what I'll do is, let us say R2 I am going to keep less value. Let us say uh, 10 kilo ohm. So in that case R1 will be 890 kilo ohm. So R2 is 10 kilo ohm and R1 is going to be 890 kilo ohm. Okay, or let us say I am going to calculate using this one, like I want this one to be in mega ohm or something. So I want 2200 kilo ohm, that is 2.2 mega ohm. In that case what will happen, my input voltage was 180 volt, Vx requirement is 2 volt. So you can see for 2.2 mega ohm this one, my R2 will be 24.7 kilo ohm. Okay, so this is how you design your circuit. Okay, now let us calculate, if you know R1, R2 and V input, what will be the Vx. So that is this. Let us say we know already what will be the value of Vx that is to be calculated. So input voltage is 12 volt, R1 and R2 are 11 kilo ohm and 1 kilo ohm, so Vx is 1 volt. Let us say you change it to 5 volt and R1 and R2 are 11 and 1 only, then Vx will become 4.41 volt. If you want to change R1 to be, let's say, 10 kilo ohm and R2 to be, let us say, again 10 kilo ohm, so this will be half of that, that will be 2.5 volt. So you know I already calculated, right? If it will be 3.3, what will happen? Both are 10 10, so 3.3, so this will be half of 3.3, that is 1.65. So it will be 1.65. Understood? So this is how you calculate the node voltage when you have R1, R2 and input voltage known. Understood? There is a possibility that if R1, R2 are known and Vx is known, what will be the input voltage, V input? That is another question. So what I'll do is, this is my Vx 1 volt, R1 is 11 kilo ohm, R2 is 1 kilo ohm, then Vin will be 12 volt. Let us say if I want Vx to be 1.5 volt, then accordingly you can see V input has to be 18 volt. With these two resistor combination, V input will be calculated to be 18 volt. Understood? If I want it to be R1 to be 10 kilo ohm, R2 is also 10 kilo ohm, then what will be V input? Both are 10 10, so it will be 3 volt, right? So this is 3 volt. So this is the complete calculation that I have calculated. So this is kind of a a voltage divider circuit calculator kind of thing it is, for all the resistor combinations like R1, R2, V input and Vx, for any of the circuits that you want to design in your electronics design principles. Okay, so alright, hope you have a good understanding of how to identify the values of R1 and R2, what is the node voltage, what is the input voltage, and how we make sure that the voltage value, the voltage division can be realized very easily in our industrial circuits. So if you do have any questions, please put down your questions in the comment box and we shall be able to give you solutions as soon as possible. Thank you.